Hello, everybody. Welcome to the sixth lesson in the quadratics unit. Last time we did common factoring, so taking out a factor that can go into each term in a trinomial or a list of other terms. Excuse me. Today we're going to use some of those ideas and go on, take it a little further into factoring trinomials. So, what factoring trinomials means is we're going to convert from standard form quadratic form, so ax squared plus bx plus c, to factored form, x minus x times x minus t. And I'm going to show you how to do this a few ways, actually, two, I think. What I want to show you is there is a handout for this. So if you go to Brightspace, again, if you want to, you can follow along with the handout and fill it in as I do it. You, of course, don't have to, but this is to show you where the notes will be. There are extra questions on here that are not in the slideshow, but I will post the solution to these so you can check your answers if you want to do them as extra practice. The the you try questions are at the end of this handout, so the practice questions. Okay, so let's go back to this. So we're going to go from this form to this form, and this is called factoring trinomials. So one way we can do this is with algebra tiles. So if we expand with algebra tiles, if we have, let's say if we have x plus 6 times x plus 2, remember if you put an x here, and now we have 6 tiles, 1, 2, 3, 4, 5, 6, and then down here, notice how we have an x side and then 2 tiles. And then we had to put these in, right? And then fill in with the squares, the little squares at the bottom. So this is an x squared tile. These are the x tiles, and these are the single tiles. So remember, if we expand this, this is how one way we could do it, or we could use our FOIL technique. So if we set up our tiles, all we have to do is count them to figure out what our equation looks like. So we have one x squared tile, and then how many x tiles do we have? Well, we have 1, 2, 3, 4, 5, 6 up here, 7, 8. So we have 8x tiles. And then how many single tiles? Well, we have 1, 2, 3, 4, 5, 6. And 2 rows of 6 is 12. So if we count those up and put them in this form, it's x squared plus 8x plus 12. You can get the same answer if we do our FOIL method, right? X times x is x squared, x times 2 is 2x, 6 times x is 6x, so 6x plus 2x is 8x, and then 6 times 2 is 12. Now we're going to go backwards. So here's what we're going to do with an example. Let's say we're using x squared plus 5x plus 6. Well, what tiles do we need? We have to have one x squared tile, 5x tiles, those are the rectangles, and then 6 single tiles. And now what I'm going to show you is you can make a rectangle out of these tiles. Remember, we have to put the x squared tile in the top left and the single tiles in the bottom right, and then we fill that in with x tiles. So here are our tiles. So I have one x squared tile, I have 1, 2, 3, 4, 5 x tiles, and then 6 x squared tiles. So if I go into here, I'm just going to show how we can make this into a rectangle. So if I move this here, so remember I'm going to put the x squared tile in the top left, and then I'm going to put the single tiles down here. Now you can put them in as many ways as you want to. You know, we could do it like this, right? We could try to make a rectangle like this with 6 tiles across here. But in order to make this in a rectangle, you would have to have 1, 2, 3, 4, 5, 6, 7x tiles. But we only have 5 of them. So we need to have only 5 spaces to fill in. So what if we do this? Ooh, that makes good sense, right? Because now I have 1, 2, 3 spaces. 1, 2, 3 spaces, and then these can go the other way, right? So we do this. Okay, so now we've made a rectangle if we put them all together. So now if we make a rectangle, that means we have the right solution with these tiles. If you cannot make a rectangle, it means you've done it wrong. So the only way you can get a right answer is if you make a rectangle. So now we can write down in factored form, this is, well, x plus 1, 2, 3, so x plus 3, and on this side I have x plus 2. Okay, I'm going to make this bigger. Okay, and if we want to check by expanding, remember if we do FOIL, x times x gives us x squared. I'll change that later. Outer, outers are 2 times x, so x times 2 equals 2x. Inners are 3 times x, which is 3x, and then last terms is 3 times 2, which is 6. Is equal to 6, and I'm just going to change this, oops, make that into a squared. So if we put these together, that gives 1x squared plus 5x's plus 6. I apologize, this is a little bit clunky as I do this, but I want you to see me do it as opposed to just looking at the slide. Okay, so that means we have factored that properly because look, we got the same equation back as what we started with. So that is how you can do it with algebra tiles. What I'm going to do is I'm going to put up some questions. Here we go. And if you can think about it, you could think about, can you make a rectangle out of these equations? So if you have one x squared tile, 3x tiles, and 2 single tiles, could you make a rectangle? And if so, write down the factors following the steps we did on this slide, okay? So I want you to pause the video, think about it, about can you make a rectangle or not? Some of you may have realized that if you can find 2 numbers that multiply to give the last number and add to give this number, that means you can make a rectangle. So pause the video right here and try to decide if you can make a rectangle out of these. And if so, try to write down the factors. Okay, welcome back. I assume that you did that and you figured out which ones you can make rectangles with or not. So I'm going to show you the solutions here. So the ones that have factored form are the ones you can make rectangles out of it. So this rectangle would have x plus 2 tiles and x plus 1. Okay, this is x plus 2, x plus 3. These two, D and F, you could not make a rectangle out of. So again, you might notice this pattern. See how the last two numbers here multiply to give the last number? And if you add these numbers, it adds to make the central number. And that pattern is the same all the way along. And that is how we are going to factor trinomials to go from this form to this form. So that's way you can do it is with algebra tiles, but I'm going to show you how to set up how you can set this up nicely with the numbers and then put it into this form. Okay, so the second technique is called X's and Oyas. So we're going to use a pattern, and these are puzzles like this. So if you look at these puzzles, if you look at the relationships between the numbers and their positions, you'll notice a pattern form. So what pattern or relationship do you see? So pause the video here if you can. Take a look at these three examples. The pattern is going to be the same in each one. Okay, so welcome back. I hope you paused it and tried to figure it out. What you may have seen and what you should have seen is that if you look at the top number, it's the two side numbers multiplied by each other. And the bottom number is the numbers added together. So 6 times 8 is 48, 6 plus 8 is 14, 9 times 3 is 27, and 9 plus 3 is 12. So here what we're going to do, we're going to do some examples. So let's see if we can find in these missing numbers. So we have 5 here and 20. So remember 20 is going to be the two side numbers multiplied by each other. So what's something times 5 that gives us 20? Okay, well, that's going to be 4. 5 times 4 is 20. And now to fill in the last triangle here, you're going to add the two numbers. So 5 plus 4 is 9. We're going to do the same thing here. 4 times something is 32. So that's 8. And then in the bottom, you're going to add those two numbers. So that's 12. Let's do some more difficult ones. These have negative numbers. So 3 times something equals negative 42. So to figure that out, you can do negative 42 divided by 3. Use your calculator if you need. It's negative 14. And now the one in the bottom here, we're going to add these two. So 3 plus negative 14 gives us negative 11. And over here, we're doing the other way, right? So 3 plus something gives us negative 24. Well, if I added negative 27 and 3, I would get negative 24. So up here, remember, we have to multiply these two numbers. So negative 27 times 3 is negative 81. So see how we're doing finding two numbers that multiply to give a number and add to give a number, another number? Just like I was describing when we were working with the tiles, this is the pattern we are going to use for factoring. So this is how we're going to set it up for factoring. So let's solve these puzzles first. What are two numbers that multiply to give 30 and add to give 17? Here you're going to figure out what are two numbers to multiply to give negative 36 and add to give positive 9. And on the bottom, two numbers that multiply to get 100 and add to negative 29. So pause the video here and try these out and see if you can get the solutions. Okay, welcome back. I'm going to post the solutions to these now. Okay, so hopefully for this one you found 2 times 15 gives 30 and 2 plus 15 gives 17. Over here, 12 times negative 3 gives negative 36. If I add those, I get 9. Here, negative 25 times negative 4. This one's challenging because you had to know you had two negative numbers. That gives us 100 if I multiply, and if I add them, I give negative 29. Okay. So we're going to use this method to go from a puzzle like this to our factored form. So here are the steps. So what you're going to do if you're given an equation like this, you're going to put the last number in the top of the x. So 12 is the last number, you're going to put it in the top. Put the number of the second term in the bottom. And now you're going to solve the puzzle. What are two numbers that multiply to equal 12 and add to give 8? And then once we have that, we're going to write them as x plus the number here times x plus the number here. And then we'll check by expanding. So let's do that. So two numbers that multiply to give 12 and add to give 8. So 1 times 12, that doesn't work. 2 times 6, 2 and 6 work. So 2 times 6 gives 12, and 2 plus 6 gives 8. Okay, so to write this up, you're going to write x plus whatever this number is here times x plus whatever the number is here. So let's check this by expanding. If we do our foiling, you'll get x squared plus 6x plus 2x plus 12 equals x squared plus 8x plus 12, which is what we had before. So we have changed this form, our standard form, into factored form. And that's what we need to do. So that's what you're going to do with the rest of the practice questions on the handout. I think there are 4 of them. I have posted the solutions on Brightspace. I have also posted extra practice questions on Knowledge Hook, and it's called the 4.6 mission. Once you feel comfortable with that, you can do a 4.6 quiz, which is on Brightspace. The first few, I think 3 questions are just can you figure out the puzzles? And then the last question is going to be can you change from standard form to factored form? So that is it for today's lesson. Please let me know if you have any questions. Um, the next lesson is going to be word problems, and that's going to be the last, um, what am I looking for? Last lesson for this unit. Um, so you have learned what you need for this unit so far, and tomorrow we'll do some word problems. Okay. If you have any questions, please let me know through Brightspace or you can shoot me an email. Okay, thanks guys. Talk to you later. Bye.